In this question, we are given the differential equation dy over dx equals to x squared minus 1/2 y. And we need to find the second derivative of y with respect to x, in terms of x and y. So let's look at what dy over dx squared is, and this is a derivative of this derivative. So it's d over dx of dy over dx. And so let's differentiate that with respect to x. It's going to be 2x minus 1/2 dy over dx. And so we need to plug in dy over dx here, and we get 2x minus 1/2, and then plugging in x squared minus 1/2 y gives us this expression. So this is our final answer. So in this question we are given this particular solution y equals f of x that passes through the point -2 and 8. And the question is whether the graph of f has a relative minimum, maximum, or neither at that point. And so let's first check whether that's a potential minimum or a maximum. So let's calculate dy over dx at the point -2 and 8. Plugging in those numbers here, we get 4 minus 1/2 times 8, which is equal to 0. So this is a point at which potentially can be a maximum or a minimum. Now let's look at the second derivative. We just calculated d2y over dx squared, and again at the point -2 and 8. And the formula we had 2x minus 1/2, and then we had dy over dx at that point. So plugging in 2x here gives us -4, and then dy over dx 0, so minus 0, which is -4, which is less than 0. So we have that at that point -2 and 8, the first derivative is 0 and the second derivative is negative, which means that that is a relative maximum. So that point is a relative maximum. So in this question we are given the particular solution y equals g of x that is passes through the point -1 and 2. And we need to find this limit as x goes to -1. And so let's look at the numerator and denominator, plug in -1. We get g of -1 minus 2. This is actually 0. And also 3 -1 plus 1 squared, this is also 0. So we have a limit 0 over 0. Let's use the L'Hopital rule. And so this limit that we have, x goes to -1, g of x minus 2 over 3x plus 1 squared. Let's differentiate numerator and denominator, will give us limit as x goes to -1. Derivative of the numerator is g prime of x over 3 times 2, 6, x plus 1. Now let's look at what g prime of -1 is, and this is equal to dy over dx at a point -1, so it's -1 squared minus 1/2 times y, which is 2 times 2. So it's again 0. Numerator is again 0. And the denominator we can see is 6 times -1 plus 1. The denominator is also 0. So we have to continue apply L'Hopital rule here. So this is equal to limit as x goes to -1. Second derivative g double prime of x, and the derivative of the denominator is 6. So we already have 6 in the denominator. Let's see what g double prime at -1 is. And the formula that we showed in part 1 was 2x minus 1/2 dy over dx. So dy over dx is g prime at -1 is 0, and so we plug in -1 here, this is equal to -2. So our limit is equal to -2 over 6, or equal to -1/3. So to find this limit, we had to apply L'Hopital rule twice, and so this limit is equal to -1/3, and so this is our final answer. In this question, we are given that h of x is a particular solution to this differential equation with the initial condition h of 0 is equal to 2. And we need to use Euler's method starting at 0 to approximate h of 1 with 2 steps. And so h of 1/2, that's halfway to 1, is approximately equal to h of 0 plus h prime of 0 times the step, which is 1/2. H of 0 is 2, so this is equal to 2, plus h prime of 0, let's plug in those values here, is going to be 0 minus 1/2 times 2 is -1 times the step 1/2, which is equal to 2 minus 1/2, 3/2. And then the second step is h of 1 is approximately equal to h of 1/2 plus h prime of 1/2 times 1/2. And so this is equal to h of 1/2, we just calculated the approximation is 3 over 2 plus the derivative at the point 1/2, we plug in 1/2 here, it's going to be 1/4 minus 1/2, and then instead of y we plug in what we just estimated to be h of 1/2, which is 3/2 times 1/2. So this is 3 over 2 plus this expression here is negative 1/2 times 1/2, 1/4, negative 1/4, 6 over 4, this is equal to 5 over 4. So the approximation h of 1 is equal to 5 divided by 4. This is our final answer. Thank you, and I will see you in the next video.